Hello guys, welcome back. In this final episode, we're gonna tackle shadings and Phong reflection model and all type of shading, flat shading, Gouraud shading, and Phong shading. So we're gonna first start by we divide our things in three parts. We're gonna implement interface for light and material parameters. We're gonna implement Gouraud shading and interface for switching between flat shading, Gouraud shading, and Phong shading. We're gonna implement the Phong shading also, and we're gonna implement the changing of direction using mouse drag and the keyboard with WASD. So let's get started. uh, okay, so let's first check what we have done previously. We have implemented flat shading. I don't want to load the object, so not to slow down our CPU. So let's go directly to the interface thing. So to start, we need to change some couple of things in the style. Let's do the display flex. Okay, display flex, and let's do the flex direction. Flex direction to be of row. Yeah, of row. Okay, let's see. Okay, correct. Now we have to display some couple of stuff. What is happening? Normally it should I think it should suggest, but it's not suggesting. Okay, anyway, so um, first we're gonna do border. No, let's take the width to be of 300 pixel. Let's take border to be of solid 2 pixel and gray. Okay. Perfect. Gray is not very good. Let's set of maybe black. Okay, so we need border radius of something like 13 pixel, and we need margin left to be of 5 pixel. Okay, should be right. Okay, perfect. Maybe 10 pixel. Okay, good. So now we need let's set our P. What is happening? It's not suggesting. Okay, our P is light parameters. Okay, and below that um, let's display another div. I think I will have problem to go fast a bit because it's not suggesting. So that one we're gonna take this style border of solid 2 pixel of white border radius of 13 pixel, and we want okay, width to be of maybe 85%. Perfect. Now let's take some stuff here that we already had, and we know that we need color. Okay, let's take this for the light material. What is happening? There is a problem maybe. Okay, let me check my recording and see it's working properly. Okay, let's set as a light ambient. Ambient. This one, let's take type of color. Okay. Perfect. This one will be of light diffuse. Diffuse. So will be light specular. Specular. Okay. And now we got another problem. Let's span it. Okay, now we have to, let's see. Okay. Okay, we have to display flex direction to be column, and this one is border. Okay, perfect. Let's set padding to be of 5 pixels. And the last one, yet not the least, is the position, which will be comprised of input. Okay, let's say light position, which will be, let's say, light X of type number. Y Z. Okay, max max is equals to 1, and min is equals to -1, right? Okay, perfect. Let's set this step to be of 0.5. Okay. Float maybe left. No. It's not the right one. Okay. Flex, display flex, flex direction column. I'll come back. So yep, we get the ambient color, right? Diffuse, specular, position, everything is set. Now we have to just include the rendering button so that we can start checking there. Okay, this one, the button will go here. Okay, id, let's say render, type button, let's say render, okay, type button. Perfect. This let's say margin bottom to be of 5 pixel. No, not this one. This one. Okay, perfect. So let's include also the light material things. I think I'm just gonna copy this one till here, right? And just paste here. Let's say material parameter, wherever it's light should be material. No, material. Okay. Here it should be shininess, and which will just be of one input. Okay. And for this one, the minimum is 0. Let's set the step to be 10, and there is no max. But because we don't want to get like this, like 10.5 that, so we say on input, so this that value equals to math that, or should we just floor it? Floor this that value, right? Material shininess, material shininess. Let's set 30 point. You see, directly we floor it. Okay, so 30.5, no, it doesn't. Okay, perfect. Now there is one more thing to do. Margin bottom, let's say 10 pixel. Okay. The default value should be let's say value default is 100. and this one uh, light position. Okay, let's set value to be 0 0, default value. Light position was Z, right? That was a default. Okay. Okay, perfect. Now what we want is to process all the input. Okay, everything is set. Material diffuse, material specular, material shininess. Okay. Now for that we need to update our here. Let's set get reference to the light parameters. Okay, document get element by ID, and we need light ambient that on change on light change. Okay, light ambient, light diffuse, light specular, light position, which is X, which is Y, Z. Okay, now we have to define the function. Okay, function. Okay, let value equals to e dot target dot value. Okay, now we switch between e dot target dot id case where it is a light ambient, case where is a light diffuse, case where is a light specular. Okay. um, let red equals to, now we have to parse it because we get it in RGB, so we have to parse int take the value, let's say that's substring because start with it start with sharp, so we forget the sharp, so we start with 1 and we take 2 and the base is 16. Okay, okay, red, green, blue. This one 1 2 start with 3 3 4, we start with 5. And then let's set okay, we have to take light dot position equals to vec oops, it's ambient, light ambient equals to vec 4, which take red divided by 255 green divided by 255 and blue divided by 255 and 0 0. Like red, green and blue. Diffuse, same thing, we just need to change here, diffuse. Specular, same thing, change to specular. Now light X, just need to take light, the position 0, which will be the value. So it's 2. If we finished light change, then we re-render. But if we click on the re-render button, okay, let's create here re-render, which takes nothing, we just call render. Re-render light change here. Okay, get reference to the render button document that get element by id, which is re-render that click on re-render. Okay, let's say we change ambient to blue to red, right? Okay, it works. It works. What about the specular? Ambient. About the light position to here. Then let's change the light position to here. Let's change it to -x, light position. Check the light. We have the light here. Position. Ambient, diffuse, specular. Okay. Okay. So I guess we need to do the same thing for the, not really the same thing, but yes. Okay. Okay. On material change, then we take let's say material material dot shininess equals to the value. Material shininess. Okay. 30 minutes. I think we will be catching up, no problem. Okay, now let's get reference to the material parameters. Document get element by ID of material ambient pattern change. Let's give it to this material shyness, material diffuse, material specular. There is a problem on change, on material change. Material, material. Material. Okay, and then perfect. Let's check the shininess to be of 10. Let's set it to 500. Yep. Okay. Specular to be yellow of 10. Yep. Okay. What if we set the light position? Change the light position to 1. Doesn't influence it. Option. Now let's load something and check the light position. Okay, the light position is minus in Z. Now let's change it to minus X. It doesn't. Minus X. And Y doesn't. Okay, let's check here. Light X, light Y, light Z. Let's check here. Light X, light Y, light Z, type number, step value 201. Okay. Light change. Okay. Light X value light Y 0 1 2. Okay, let's console.log the value and see what is the problem. What happened? Light position. Light position. Ah, okay. I said it like it's not light. Right? It's not even light. Light. Okay. Light. Okay. Here it's light. Okay. Perfect. Okay. 45 minutes. Wow. Okay. Let's hurry up a bit. My position. Console log. Now we managed to interface like material parameter works properly. Now let's quickly implement our Gouraud shading, and then we implement the switching interface of that. Our Gouraud shading is mainly what we need to do. We just need to accumulate the normals that can to then accumulate normal of faces to their vertex. So the vertex that contribute to one polygon, we accumulate the normal of the polygon onto the vertex. That's it. That's what we need to do, and let's do it a bit quite quickly because we have a lot to do. Let's implement map to keep track of the vertex contribution to polygon. Vertex index. Triangle with normal that contribute to polygon. Okay, for this let's set vertex, let's call it vertex index. Normal. Okay, let's just call it vertex index, which is equals to new map. Okay, keep prepare value. That's why we need to, the key will be the vertex, which will be in the string format, and the index will be the value. Okay, so here we push here. So the Gouraud shading, because we're going to implement Gouraud shading, we have flat shading, Gouraud shading, and Phong shading. So to do that, let's also take checking which types of shading model. Okay, if model dot set, let's say flat shading, which you're gonna define later, is true, then we just push normal like this. We just push normal like this, but else if model dot set Gouraud shading, or because both will need the same type of normal of set Phong shading is true, then we do the magic. Okay, so for this, what we need is that we need to check if the vertex index has our vertex has a key to string. If it has it, which means we just need to accumulate, right? So we take let index equals to the vertex index of v to string, right? Which is the key. And then we take the triangle vertex normal so the triangle vertex normal of that index should be accumulated, right? So we will add that normal, let's say triangle vertex normal of this index. We add it to the current normal, but we need to normalize it. Okay, so but we need to push the updated normal also in the triangle current position, because if we don't, because our triangle vertex normal are pushed per vertex, it doesn't matter duplication, so we have to push also the duplication, which is a triangle vertex normal that push we have to push this one. Okay, we have to push that one. Perfect. If or else it's not there, so what does it mean? It means triangle vertex normal, then we just push it, the normal, and we just take the index. The index will be that set v that to string, and the index will be triangle vertex normal that length and the surprise -1, because yep. And I guess that's a Gouraud, right? Let's see if it's working. But for now we stop. Let's set all of those things before. Model vertices. Okay. Rendering parameter. Set flat shading. Set Gouraud. Oops. Shading. And then we have to set Phong shading. Okay. So at the beginning, this dot set flat shading is default one. This dot set Gouraud shading will be false. This dot set Phong shading will be false from the beginning. Okay. Let's check the thing. Almost 1 hour. So everything will be like this. So flat shading here. What is the Gouraud shading? Okay. Now. Okay. The Gouraud shading is implemented, but let's implement the interface so we can manipulate it. And to do that, we need this and this. After the canvas, okay, left, shading interface. Shading models. Okay, perfect. For this, we will be needing something like this too. Okay. Okay, padding, display, bolt. Okay. Okay, so for this we need let's take here something here. Okay, let's take this. So just need to set it to radio so that it's, and then check, and for this one it will be this one will be flat shading, right? But I guess we don't need that because name will be flat shading, and ID is already flat shading, and value, anyway, we don't even need the value, we just need the ID. New value, let's see, flat shading. So cool, so far so good. Flat shading. This one will be Gouraud shading and Phong shading. Oops. Gouraud shading and Phong shading. The name here will be Phong shading. Here is Gouraud shading. Okay. Checked. Okay. Let's set the value to be flat shading. Good. There is a problem. ID, Phong shading, type radio, name, Phong shading, value, I think. Okay. So our problem was that um, the name should be equal to be specified that we all buttons belong to the same. Yes. Okay. Let's see. Yep. Guru shading, Phong shading. Perfect. Now what we have to do is to display span. Span. No. Uh, let's set the style to be display or flex direction of column. Okay, perfect. Here, let's say margin top to be of maybe 20 pixel. I said 20%. Okay, if it's that, so let's say 40. Okay, perfect. Now we have to take all the shading, Phong shading, and all of that in the is it here? What is this? Okay, let's take from here. Okay, now get reference to the shading model parameters. Okay, document that get element by id of our flat shading on shading change. That on changed. Phong shading. Okay. Um, let's switch between e dot target dot id. In the case of flat shading, we take the model that set flat shading to true, and we take the model that set Gouraud shading to false, and we take the model, we set the Phong shading to false, and we break. Gouraud shading. Phong shading. Phong shading is true, false. Gouraud shading is true, false. Okay. If the shading something, then we render, but we don't wanna we re-render, but we don't re-render, we just call the so that it processes the objects again. So we just need to call onloading, but if we call onloading, it cleans the tetrahedron, so it's meaning we have to check if we have loaded something. So if, let's say, model that file loaded, right? If file is loaded, then we call on loading, else we just re-render the tetrahedron. Okay, now we have to implement this one. Where is set Gouraud shading? Okay, file loaded. This dot file loaded equals to false, and this one we will have to do it in one function that processes a file when it is loaded. I think it's in the loading here. On file loaded. No, not here. Load from file. use here. Yep, it's here. That's the previous code. Okay. Now I guess Gouraud shading should be working. Let's load. Okay, Gouraud shading. No. Okay. On shading, set Gouraud shading is true. Yes, alert. Let's console.log. Yes. Okay. Flat shading. Okay. So the problem is probably flat shading is true. Gouraud shading false. Oops. Just a second. Gouraud shading. Okay. Okay. If model, that's it, Gouraud shading. Then if vertex that has v to string, let index of v to string equal index. Then we add the normal triangle vertex normal index. Triangle vertex normal dot length -1. Triangle vertex normal dot push triangle vertex index, the updated one. Let's see if flat shading, Gouraud shading, and what did I set? Phong shading. we get the normal, calculate those things. Nothing has changed. I think because of the legacy code that we have, let me remove this and see. Teapot. There is a problem. Okay. I think we got a bit of problem. I didn't clean the legacy that I calculated in the fragment. No, we will be doing it later. Uniform, shadiness, Phong shading, all of that for the fragment later. Have normal, this one, no. Light vector, okay. Here we did specular, anyway. This one, no. KD, model hue, varying, normal, light, data, shadiness, projection. Okay, let's try again. Let me welcome. I guess our problem was that we used the bracket, this one, but it's supposed to be dot get. Yes, that's the problem. And let's see our vertex, our Gouraud shading. If it works, then we go to implementing the Phong shading quickly because we are quite late. And yep, as we can see, our Gouraud shading is working. Okay, I keep shifting. Yep, let's try to change to gray. Yeah, that's the Gouraud shading. You can see the specular is quite bigger when it comes to Gouraud shading, but the Phong shading will have different specular. Okay, good. Now let's go back and try to implement the Gouraud shading. And the Gouraud shading, mainly we're gonna work inside our program. So first we need the normal, and we know in Gouraud shading we have to calculate. Let me show you. We need to calculate. We need to calculate the KD and KS, which is a diffuse coefficient, and I mean diffuse absorption coefficient and specular absorption coefficient. So, and to calculate that, we need normal, light vector, and halfway, which means we have to send all of that into shader so that it can be interpolated in the rasterizer, so we get it into shader, I mean fragment shader, then we calculate those things. Okay, let me just copy this one and I'm gonna paste it here. Okay, KD, but we need it to be V light, which means varying normal, varying halfway, varying normal, and shininess, let's say frag. Everything we send to frag, we put it to frag, I mean in terms of uniform one. So what, which means we have to say varying of vec 4, so vec 3 of normal, and same thing varying of vec 3 of V light, V light vector, and varying vec 3 of V halfway vector. Okay, we also need uniform variables for illumination parameters, which is uniform shininess is just a floating point, U shininess frag, and we will need also uniform of vec 4, which is U ambient product of frag, uniform. Okay, let me just copy this. We need also one thing, uniform, but it will be bool to check if we have to consider the Phong shading. Okay, this one is ambient, this one will be diffuse frag, and let's say this one is specular product frag. Okay, and when we get it right, check if using Phong shading, if Phong shading is true, then else just say get the color interpolated. But if it's true, then we get the GL frag color, which is equal to ambient plus diffuse plus specular, and then GL frag color of the alpha will be right. And to get those things, we need to declare them somewhere. Vec 4 ambient, which is equal to k u ambient product frag and vec4 of diffuse, which is equal to kd times u diffuse frag, right? And then the vector, which is specular, is equal to ks times u specular product frag. Okay. Calculate our overall illumination parameters. What else? When we get this thing, calculate interpolarity, calculate it, okay, which means we have to get those varying here, and as soon as we enter send varying to frag shader, which is v, we cannot send it here, we'll send it after we calculate those things. V normal equals to normal, and V light vector equals to light vector, and V halfway equals to halfway. Okay. What else? What else? What else? What else? Okay. From the fragment, we get the varying, we calculate, we get the frag, we get what is this thing, we calculate, we check if it's this, we calculate, if it's not, we just take correct one. The shininess should be used here. Okay. I think everything is set here. Now we just need to implement those variables in our program. Animation variables. Frag value shininess, so frag, and what else? I guess that's it. Okay, so let's copy this, even this, we'll set it here. Frag flag. What else do we need? Just one. Interpol is a normal. We get it. Correct. Now we have to send it through here on the rendering. Send illumination parameter into GPU. Even this one. Frag. Okay. Now let's check if we get okay, teapot. We get then the Gouraud. You see it's big. Let's see the Phong. It's small. Okay, let's check. Okay. There is one thing we didn't send. It's called Phong shading. Phong shading, which is dir that get uniform location. The program, it's called Phong shading. We need to define it, which is a flag to say that we want to use the Phong shading, right? And for that we need to send here also. Okay, I think we will need this one, but from another type it is int, and because int in boolean in C type language, it is the same thing. So we get the model that set Phong shading. Okay. Okay, let's check Gouraud shading. Phong shading is more, yes, it is more okay, let's set 200. Let's change the color with red. I think it's more visible, right? Okay, that's Gouraud shading and Phong shading. You can see the illumination change. I mean the specular becomes so small when it's Phong shading, right? Perfect. Okay. See? Perfect. Now what we need to do now is changing the direction and mouse thing. Okay. Okay. For that we need some couple of functions. Let's say on mouse move we do something. Mouse down, mouse move, then mouse up. E dot prevent default. Okay, our frame is working properly. Okay, on mouse down, what we should do, we should take let rect equals to e dot target dot get bounding client rect, and we need to take let x equals to e dot client x, and let y equals to e dot client y. And what we need, if let's take if x is greater, no, first we need to know if we are in the canvas, right? If e dot target dot id is equal to our id is gn canvas, right? And now if x is greater than right that left, which means we are inside the canvas, and if we are not outside also. If x is less than rect that right, and if y is greater than rect the top, and y is less than rect the bottom, and then we set the dragging to be true, that we are dragging, and we set the prev x to be x and the prev y to be y, and we set the last time to be date dot now. It's not suggesting for me now, anyway, and we need to declare those variable up there. Okay, we declare them here. We say mouse control variables. Dragging is false. Default is false. Okay. So here is set. Now when if we are moving, we have to, okay, let's first take let rect equals to e dot target. Do we really need it? Okay, let's see. Let x equals to e dot client X, and let Y equals to E dot client Y. Now if the dragging is true, if we are dragging, now let pass time equals to date dot now, and ah mm, it's like date dot now minus last time. Now if the pass time is greater than 10 milliseconds, then we have to do something, but let's update our last time. It is equals to date dot now so we take, okay, we increase because we are moving in the like this, so it's like a semicircle. Let's say it's a sphere, so we are in the middle of the sphere. So if we move, right, so it's like we have to use a parametric equation of the sphere to get the position, right? So but let's consider this move as a degree, right? Degree. So if we move like this, the yawn will be 360. But if we move like this, let's say it's 90 degree up, 90 degree down. So that's a gap we should stay inside. And so what does it mean? It means model that u is equal to let's say we have the intensity rate, which is time of the x minus prevex. Oops, prevex, right? And model that pitch is a vertical angle is a pitch. Pitch times, because we have to flip it, so it will be the previous y minus current y. But we don't want the pitch to also go 360 degrees, so we have to check if the models that pitch is greater than maybe 90 degree, and then we set it back that pitch. We have to declare it, those pitch and u later in the model, equals to 90 degree. If it is less than minus that one, set it to that. But I think it's better to set it to 89, because 90 will flip to 0 or something like that. Let's set it to 89 to avoid any problem. So now we get right. So this one will go, yon will go 360, this one will go um, what we call it will go 90 up, 90 down, right? 89, let's say. So using this sphere parametric equation, then we can get the position, the point in the space, right, where he is looking. So we're gonna use, let's say, model dot come at, which should be at. You remember the look at function is I at and up, so the at is come at, which we're gonna define later in the model, which will be vec of 3, and we know that it will be math, because it will be r sign, but normally using the sphere equation we start like this, then right, but for this one we want to start like this. So if we start like this, which is our 0, and if we go up, which means the vertical component will be sine and the horizontal component which will be cos, right? So map that cos of our, because pitch is like this, so the sine and the cos, and the cos will be the cos will be r cos of, r cos will be the r of the p of the unit. Okay, yes, okay, so let's take model dot u convert it to degree, to region, times math dot pi, and then we divide by 360, because we want to go 360, and also it also decreases the velocity anyway, and math dot cos of model dot pitch times math dot pi divided by 360. That's our x. Remember, in the sphere of equation, it is x is like r r sine of theta cos of phi, right? Here our phi is our theta is pitch and our phi is u. So the y will be our, in the sphere of sphere, the z is like this, but for us y will be vertical one. So math that which will be, if it's vertical and we start like this, it will be sine of the angle, right? Sine of model that pitch times math that pi divided by 360. And the last one, it will be sine here. Remember, in our circle, which is a base, the x is cos, the z is sine, and r cos is r cos of pitch is the length of the r in terms of the radius, in terms of the circle, base circle. Okay, so when we get the come at, what we need to do is to now call our transform every time, right? Transform and render, but we need to update the prefix. Oops. The prefix equals to x and the prev y equals to y. Basically that's it. So if we up it, we set the drag be false. Now we have to declare all of those yawn and pitch in the model in the command. Then we update our transform our model view matrix. Okay, let's update our model view matrix here. Okay, let's set this one is campus, which is the position of the camera. Okay, it is 2 model.campus, and this one is model.come@, and this one will be come up, model.come up. This.come@, will be equals to vec3. Okay, initially it's like this, but we're gonna have to change some stuff because we want to move back and forth. So we know that the come@, will have to be the vector of translation, I mean in the z-axis. So the z has to be something, let's say -1. Okay, campus, which will be vec3 of 0 0 0 and 2 0. And as I said, as you see, the camp position has to change, and what can change it will be the come@, because we will be adding it. So if we want it to change, we have to add it to the position. So we change, we move. If we minus, right? So for that, it means here also we have to modify it in our here. So which means here it will be add of model that campus and model.come@. Okay. Okay. Yep. Now we have this that come up, which is vec3 of 0 0 1 0 0 0. Now we need something else, our yawn, and to start our yawn will be -180, because usually we look at this arts here, right? Because the z is looking here, right? So that's why we need to flip it like this. In the camera position, the z is here, x and y. So as the yawn shows the position of z, we have to flip it. So it's -180 to look at back there. And this pitch, which will start by 0 0, right? 0 0, like this. Okay, and let's define everything here. Rendering, let's say mouse params. Okay, pitch, yawn, cam at, cam pos, and cam up, right? I think now everything should be working. No, there is a bit of problem. Unexpected token, syntax error, 562. 562 is here. Okay. Okay. Dragging is not defined. 63. 63. Oh, okay. var 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 var. Okay, let's see. Hmm. What is happening? Dragging, mouse down dragging is true. Eric, left, right, top, bottom, dragging, past time, date now minus greater than 10 millisecond, last time now, yawn, x minus prefix, transit, okay, pitch, okay, cos, yawn, times math by model pitch 360, command, transform, xy, dragging false. Okay, camera transform, campus, come out, come up. Uh, if dragging is true, last time, pitch is not declared. Pitch is here. Pitch. Okay. What else? Yo, command. Yo, command. Come at minus, come plus 2. Okay. Pitch, sine. Cos of pitch, cos of yo, pitch, pitch. Pitch, 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 pitch. Okay. Yo, yo, yo. Okay. So what is the problem? Console log. Model yo. We got some problem. Let's see here. The mouse wasn't moving. Okay. So the issue is related to dragging. Okay. This one here, dragging through e.target.id equals to gl canvas and x is greater than rec.left target get bounding client rec bounding client rec, correct. X less than rec.right, rec.top, rec.bottom. E.target. Okay. Let's console.log e.target.id and console.log here. Oh, I didn't apply the function. Okay. I did apply the function yet. How is it supposed to run? It's here. Window that mouse move Okay, now everything is working, but we can see that we are looking as if we are looking in the sphere because of the formula we use as the sphere, right? Okay, and the perspective is quite visible like this. Okay, now direction is done, keyboard changing, and for that we need just to modify these things here. Okay. So W, oops, W S A D, right? So for W, we do model dot composition of 0 increase by the model. That's why we had to add composition to the command, because when we move, we have to move also. It's like a vector, right? We have to move both of them. So when we increase, we have to add, because at the end of the day, we're gonna subtract in the lookat. So yeah, it's quite a long. It needs quite a long explanation. Add of 0. Okay. Which one is 1, 2. So 1, 2. Okay. And when it comes to S, which means we are going backward, we just need to decrease it. Right? Minus, minus, minus. Now the problem comes into the A, and as A is left, we need to define another vector, which is left, which is a cross of, oops, cross of model that come because the Z is campus cross campus cross up will be like okay, let's try to do it. We can change it later. And come up, yeah, come up. So then we apply this thing here, but with the left. So and then this one is left, right equals to the same thing. Actually, if we cross the opposite, we get the same thing, but we're just gonna negate. That's it. So it will be this one, and let's say right. but it will be minus, right? Let's see. Okay, I didn't decrease the speed of the, okay, it works, you can see. But for A should go left, D should go right. But there is something wrong. Okay, this one should be plus, and D should go to plus, and then minus. Okay, let's see. Okay, A, yes. There is something wrong. A, it's going back, right? So which means we have to normalize the cross we get. We have to normalize. We have to normalize A, D, A, still going back. Okay, let's see. Okay, let's add the speed first. Yeah, we have the speed here. So for every of this, let's say we take this, we add the speed times this, okay? And for every of this, speed times that. But there is a bit of problem. Normalize left, normalize left, right, cross, compass, model data. Ah, okay. We cross the come at. I think we have to put the come at, because in reality the at doesn't change, but the post change. So up and yes. Okay, let's check again. A, D, S, W. Okay, let's try. Let's use, okay, we can do 360. 360 works. Up, remain into the range of 90 degree. Okay, and A, yes, works, but it seems like we rotate it a bit, right? Or is it because okay, yeah, thank you. We did 3 hours, right? 2 hours. Okay, thank you for your attention. Let's switch to Gouraud shading and Phong shading. Move S, move A, move D, move back, move forward, and we can turn. Yep, you can see works perfect. Change the direction. Cool. Flat shading. Let's change the light, change the material, diffuse, maybe diffuse with blue. Okay, Phong shading, Phong shading. Okay, thank you so much for your attention.